In the chemical reaction presentation, we learned about another reaction other than single displacement, double displacement, synthesis, and decomposition. We learned one of the special reactions that is called neutralization. And neutralization deals with acids and bases. So what exactly are acids and bases? Let's take a look. An acid is a solution that has an excess of hydrogen ions. It comes from the Latin word acidus, which means sharp or sour. The more hydrogen ions there are, the more acidic a solution is. So here are some properties of an acid. So when I say the word acid, you probably think of acidic foods, like something that tastes very sour. Well, anything that has acid in it will taste sour. That's one of its main properties. Why? Because it has the property of dissolving into water to form hydrogen ions. And these hydrogen ions, they conduct electricity, and they're also strongly reactive with metals, and they can corrode certain substances like paper, fabric, and skin. So some supplies that are used in cleaning, for instance, some of those supplies are very corrosive, and those will actually corrode through your skin. So one of the main properties of an acid, especially with litmus paper, is that it turns any blue litmus paper to red, and that indicates that it is an acid. Let's take a look at some common household acids. So vinegar is one of the common ones that you may have in your cupboard right now. Its scientific name is acetic acid. So that's generally used for salad dressing. Citric acid, anything that has citric acid is going to be a fruit, or it could be a candy, like those Sour Patch Kids. Those have a lot of citric acid in them to make them sour. Ascorbic acid is something that we need to survive. Vitamin C. Lactic acid is what's in sour milk. And it's also what builds up in your muscles when you go for a run or something, and then all of a sudden your muscles start hurting so much. What you're feeling is that lactic acid buildup. Acetylsilic acid, that is aspirin. Hydrochloric acid is your stomach acid. You've even got an acid within you. Chloric acid, any explosives. Nitric acid is what you find in fertilizers. Carbonic acid is what's in carbonated drinks. Sulfuric acid in car batteries, and phosphoric acid, which is a cleaner, or it's used in fuel cells or the MRI machines, the magnetic resonance imaging machine. Now, you'll be able to recognize most acids because generally they begin with the hydrogen element. So all of these acids that you see all begin with the hydrogen element except for acetic acid. Here are some examples of reactions with acids. So the first example, we have a solid zinc, which is a metal, plus hydrochloric acid. That's like our stomach acid. Now, notice the symbols that are subscripted down here. You haven't seen those before, or maybe you have, but you do need to know what each of these little symbols stands for. So here's a little chart to tell you what phase of matter it is. So the S represents a solid, Q represents an aqueous solution, which means that it is dissolved in water, and then the G represents a gas, and the L represents a liquid. So you have a zinc solid plus hydrochloric acid, which is mixed in with water, so maybe its concentration is lower, and you end up with the product zinc chloride and a diatomic hydrogen molecule in gaseous form. So you can only predict in this reaction, there is some gas that's released, so maybe gas bubbles are released, and then you also get a salt being formed. So a salt is anything that has a cation plus an anion. So we've got a zinc chloride dissolved salt there. And then we have this reaction combining hydrochloric acid with calcium carbonate, solid, and it produces carbon dioxide gas, water, liquid, and calcium chloride salt in aqueous. So that means there could be some calcium chloride salt particles dissolved in the water, and then carbon dioxide gas is being given off. So those are some examples. Now, when an acid dissolves in water, it's represented as the aqueous. It dissolves into water and dissociates into its hydrogen ion and its nonmetal ion. So if you were to take this HCl from this reaction and only dissolve it in the water, so forget about the calcium carbonate here, it would produce hydrogen ion and chlorine ion. Okay, and then those two things go on to react with other things to make full compounds. This is something we'll get into more in grade 11. So what is a base then? We've already looked at acids. What's a base? A base is a solution that has an excess of hydroxide ions. So another word for base is alkali. And bases are substances that can accept hydrogen ions. And let's look at some properties of a base. So when I say base, you probably don't know, or you probably haven't seen what that is. Now I've got a picture of soap here. Now, if you guys were like me when I was a kid, unfortunately, I had my mouth washed out with soap quite a few times, let's just say that. And it's not the greatest taste. Although soap smells very nice, oftentimes it is very, very bitter. And the reason for that is because its basic properties, okay? So any soaps are very slippery, they taste bitter. Many chemicals that contain bases in them are corrosive, and they can break down different proteins in the body. So if you have Drano, for instance, they put a warning label on Drano, and they say that it's corrosive because if you do spill it on your bare hands, that is going to eat through your skin. So it breaks down all the proteins in your skin. And it's super important that for some cleaning supplies, if you end up splashing them into your eyes, it will actually make you blind because it breaks down the proteins within your eyes. So it's important to wear personal protective equipment when you're dealing with some of these bases. A lot of these bases can also conduct electricity. Think like alkaline batteries, and another word for base being alkaline. So one thing about bases that is good is that they don't react with metals. So oftentimes they're used for cleaning supplies in the kitchen, they're used to clean ovens, they're used to clean sinks, for pipes, they're used in cars. All of these bases will not eat away at metals. And one of the special things about a base is that it turns red litmus paper blue. So we're going to be looking at more of the indicators in the next presentation. And how are bases used? I've already kind of said a couple common bases, but sodium hydroxide is a Drano. Potassium hydroxide is used in soap. Aluminum hydroxide are antacids. So those antacids, if you take antacids in like a pill form, for instance, Alka-Seltzer, that will help control your heartburn and control the acid reflux from coming up your esophagus because your stomach is full of this hydrochloric acid. It's full of all of this acidic material, and if you eat something that overproduces this acid, then you're going to get really bad burning going up your esophagus. So sometimes antacids will help with that. And then we have ammonium hydroxide, and this is like Windex. You've got sodium bicarbonate, baking soda used in foods, potassium sulfate, which is a food preservative. Now, the hydroxide ions will interact very strongly with certain substances like dirt and grease, and that's why they're generally used as very good cleaning solutions. Your blood is very slightly basic with a pH of about 7.2 to 7.4. Now, most bases, and we're going to talk about the pH in the next presentation as well. Most bases, they're easy to recognize because they contain an OH group. Notice in all of these chemical formula, there is an OH, except for in sodium bicarbonate. Now, others that don't have an OH group, just like sodium bicarbonate, these guys will react with water to form a hydroxide ion eventually. So let's see a couple of those examples. So in the first example, we've got sodium hydroxide. When that reacts with water, it breaks into its metal ion and in its hydroxide ion. Now, take a look at sodium bicarbonate. That was the only one on that list that did not have a hydroxide ion clearly in it. So if you take solid baking soda, mix it in with water, you're going to get a sodium hydroxide basic solution. And that basic solution will also have bicarbonate ions in them, and then that will further break down into sodium ion and hydroxide ions, and that's how you get the hydroxide ions out. Now, we've seen some reactions with acids and we've seen some reactions with bases. Now, what about combining both of the acid and the base? What do you get when you combine an acid with a base? I want you to pause the video here, and I want you to use your double displacement rules to try and figure out what the products are in this reaction. And when you come back, let's take a look at what these products are. We have hydrochloric acid dissolved in aqueous, so dissolved in water, and sodium hydroxide in aqueous solution as well. When you combine them, double displacement says that one of the elements or compounds has to switch with the other one, and they both swap partners. So when that happens, we get NaCl and HOH, which is H2O, water. So NaCl is a solid salt dissolved in aqueous. So if you were to evaporate the water out of this solution, you would get sodium chloride salt, which is just table salt, right? And then you also have water, which is the liquid form. So whenever you react an acid with a base, no matter what acid, no matter what base it is, you are always going to get water and a salt. And a salt is just a cation plus an anion. Now, is this dangerous when you react an acid with a base? No, it's not really dangerous because it's creating water and just a typical salt. Now, the salt could be dangerous if you consume too much of it, but the water in this case, the water neutralizes itself, is neutral. So this reaction is called a neutralization reaction because it creates a neutral substance known as water. We're going to look at the pH range where you can see what neutral is, what acidic is, and what basic is. Now, when I was talking about those salts, the cation plus the anion, here is a common list of salts that you can see that form when an acid and a base react together. In the next presentation, we're going to be looking at the pH scale, and we're going to be putting some common ions or common items on the pH scale to show you what is acidic and what is basic.